now let's cover initial value problems with separable differential equations. Well, this is not much different than what we did previously with separable differential equations, where we solve the differential equation and then we're gonna plug in the initial value. Remember guys, the initial value is a point given to you. So the input will be your x point, so this will be a 0, and the output will be your y, which is going to be -1/6. Or in the graph, it should look like something like this, where this is the point -1/6 on the vertical axis. Okay. Now that we have this differential equation, and this differential equation includes a y squared, which shows that this is nonlinear, and this is the first order differential equation. So the best method to solve this would be separable differential equations. So let's start with using the Leibniz notation. We would say dy over dx equals to 1 minus 2x y squared. Awesome. And you don't want this dx on the denominator, so you would push that to the other side. Dy equals multiply at both sides with dx, 1 minus 2x y squared dx. Awesome. Now that we have this, we want this y term with the dy, so you would divide both sides with y squared, so you would get 1/y squared dy equals to 1 minus 2x dx. Very nice. And now that we have this, we can integrate both sides. And integrating this side will give you, I'm going to write over here, well, treat this as the integral of 1/y squared would be equal to the integral of y to the -2nd power. And when you're integrating, remember that you're adding 1 from here and then multiplying with the exponent. So you're going to have y to the -1st and negative. So you would have -y to the -1st power. And if you were trying to take the derivative, you would ultimately get the same result. So this is the derivative of the left-hand side, and equal to the integral of 1 minus 2x. Well, the integral of 1 minus 2x dx is actually, we can write this as two different integrals, 1 dx and minus integral of 2x dx. I noticed that how I pushed the negative outside the integral, which we can do that because -1 is a constant. And we would have x here minus x squared. This is the integral of 2x is x squared plus c. So that I'm adding this plus c, so it would be very useful. And remember that we had -y to the -1st power on the left hand side. I'm just going to write this as -1/y is equal to what we got from the right hand side, which is x minus x squared plus c. Very nice. Now I want to use my initial condition for this question. The initial condition is y0 equal to -1/6. So I'm just going to write this real quick. y0 equals to -1/6. So anytime we see a y, we're going to plug -1/6. And anytime we see an x, we're going to plug 0. So plugging -1/6 to y will give us 6 on the left-hand side. We will have -1/6, and negatives will cancel each other out, and we're going to have 6 from algebra equal to, we're going to plug 0 anytime we see x, so 0 minus 0 squared plus c, and ultimately we know that c is equal to 6. So the solution for this particular solution, actually we are not at the explicit solution yet. I'm just going to plug the c into this differential equation, into that equation right there. It's no longer a differential equation at this point, but x minus x squared plus 6, because we found c. And now we can find y very easily. We can multiply both sides with -1 and multiply both sides with y, or we can cross multiply, and that would be much better. So first of all, we would have y times x minus x squared plus 6 equals to negative 1. And now we can divide everything with this this x term. So y would be equal to negative 1 all over x minus x squared plus 6. Here is another very good question. Since also the same way we have y squared and negative y squared in this function, this is a nonlinear differential equation in its first order, so we should use separable differential equation method. And we are given this initial condition where this 0, 1 point. Okay, and let's start working. So the y prime would be ultimately dy dx because of Leibniz notation and separable method. And we have this on the right hand side. Oops. We have this on the right hand side. Nice. And you want to cross multiply, so we would multiply both sides with this guy and multiply both sides with this guy. So it's actually the same thing as multiplying dy and the y function and dx with the x function. So we would have 3y squared minus 6y dy equals to 1 plus 3x squared dx. Now we can integrate both sides to solve the separable differential equation. We would do we would separate this integral as in 3y squared minus integral of 6y dy, and this will also be a dy, equals to integral of 1 dx plus integral of 3x squared dx. And then we would integrate. So the integral of 3y squared with respect to y is y cubed. This integral would be y squared over 2, but we have 6, so it will be 3y squared. Because this 6 over 2 would be 3, so we would have y squared over 2, and multiplying that with 6 would give us 3y squared equals to 1 dx. The integral of 1 dx will be x, and the integral of 3x squared is x cubed, and we would, don't forget your plus c. Awesome. And now is the best time to apply the initial condition where at 0 we are at 1, so y 0 equals to 1. So anytime you see a y, plug 1. Anytime you see a x, plug 0. So we would have 1 cubed minus 3 times 1 squared equals to 0 plus 0 cubed plus c. And on the left hand side we're going to have negative 2 equals to c. So our particular solution would involve c being equal to negative 2. And moving forward with the differential equation, I'm just going to rewrite it over here. Y cubed minus 3y squared equals to x plus x cubed minus 2. Let's now work on this problem. Since this differential equation, we could solve this differential equation with integrating factor, but that wouldn't be ideal because of the way this differential equation is formed. So what you want to do is use separable method. So we're going to start with using Leibniz notation, dy dx equals to 3x squared minus e to the x over 2y minus 5. Now, cross multiplying, we would get 2y minus 5 dy equals to 3x squared minus e to the x dx. And we would be able to integrate both sides, and we would split this integral minus integral of 5 dy equals to integral of 3x squared dx minus integral of e to the x dx. Awesome. Now that we have this, we are able to integrate each term and solve for the differential equation. So this term would be y squared minus this term is 5y equals to x cubed minus e to the x, and don't forget your plus c. And in order to solve for the particular solution, we know that y0 equals to 0, so we would plug 0 for both y and x, so we would get 0 squared minus 5 times 0 equals to 0 cubed minus e to the 0 plus c. This would mean 0 equals to negative 1 plus c, and this gives us c equals to 1. So we would find the implicit solution, y squared minus 5y equals to x cubed minus e to the x plus 1.